Okay, so Unit 3, Lesson 2, we are going to be solving systems algebraically instead of graphically now. So we're going to have two methods for solving two variable systems like this. And I've got the steps for one of the methods right here, and that is solving by substitution. So to solve by substitution, you solve one of the equations for either x or y. And the time we're going to use substitution is when we have just x, like one x, where it's not like 2y, 3y, where it's just x or just y, because it's easier to solve for, and I'll show you that in a second. And then you substitute the expression you solved into the other equation and then solve for that variable. So you're turning a two-variable equation into a one-variable equation. And then you get one of your solutions, x or y, and then you substitute that back into the first equation. So I think these steps will hopefully help, but I mean, demonstrating it I think is the easiest way to do it. So in this equation, or this system of equations, I think the first equation is the easier one to solve for x, because it's just x plus 2y. So I'll show you how to do that. To solve that for x, I would subtract 2y from both sides. So this equation becomes x equals negative 2y minus 2. Okay? So I have an expression for x. I'm going to take this expression, negative 2y minus 2, and I'm going to substitute it into the second equation. So what that becomes is 3. I'm substituting out x and putting in this entire expression, plus 4y equals 6. So that's me substituting out x and substituting in this expression. So I distribute, simplify, and I can solve this. So this becomes negative 6y minus 6 plus 4y equals 6. So this is negative 2y minus 6 equals 6. I can add 6 to both sides. This becomes negative 2y equals 12. And then finally y equals negative 6. So that's only half of my solution. I've got to find the x value of my solution. So what I do is I'm going to take this negative 6 and I'm going to plug it into the equation that I solved for x. So that x equals equation. So this becomes x equals negative 2 times negative 6 minus 2, which simplifies to 12 minus 2, which simplifies to 10. So my solution is the point 10, negative 6. I'd like you to represent your solutions as an ordered pair, as a point. So substitution is one way. It's not the only way. I think the elimination method is a little bit easier to pick up on, but I will show you that. And then basically I'll let you choose. Whichever one you think is better. It's up to you. But just know you can manipulate the equations to solve them either way every time. Both of these methods work for every equation. Sometimes one's easier than the other. So elimination method is to multiply each equation by a certain number so that two variables match up with their leading coefficients. So they're both 4x and 4x, or both 8y and 8y. You subtract one equation from the other, make them opposite signs, so it's like 4x minus 4x, and then you solve this new equation for y, or you could solve it for x. It depends on what you're doing in the beginning. And then you substitute whatever it is into equation 1 or equation 2 to solve for x. So I should have just said, just substitute y or x and solve for the other equation. So I'm going to kind of show that down here, where we have 2x plus 5y equals 14 and 4x plus 2y equals negative 4. So I would want to multiply either one or both equations to get variables to match up, or coefficients to match up. So I'm going to look at, I can multiply, what for me would be easiest is to multiply the first equation. And I'm just going to multiply the first equation by not just 2, but negative 2. So let me write out that negative 2 on the front here. So I'm multiplying that whole top equation by negative 2. So that top equation becomes negative 4x minus 10y equals negative 28. The bottom equation stays the same. 4x plus 2y equals negative 4. So what happens here, negative 4x plus 4x is 0, negative 10y plus 2y is negative 8y, negative 28 plus negative 4 is negative 32. So I get y equals 4. So I got half of my solution right there. And then what I can do is, beauty of this, is I can substitute y equals 4 into either equation. It does not matter. You will get the same solution for x. So I'm just going to substitute it into the top equation. So the top equation becomes 2x plus, if I substitute in 4, that's 5 times 4, which is 20, and that equals 14. So I'm just going to solve, subtract 20 from both sides. 2x equals negative 6. X is negative 3. So my solution is the point negative 3, positive 4 as an ordered pair. And you can honestly check your solutions on Desmos. Graph both of these and see where they cross. That's a good way to check your solutions. I still expect you to show the work, but that's a good way to check your solutions. So what I want you guys to do now is I want you to move on, do these 2 guided practices on your own, and then take a few seconds to pause the video and check in with me so that you can understand that you're doing them correctly or incorrectly, and then you'll kind of feel a little bit more confident, hopefully, in solving these systems. Okay, so if you noticed, I used elimination for both of these systems. So if it's set up for me, I'm going to choose elimination most of the time. If you're more comfortable with substitution, by all means use that. But if elimination, I think that's the easiest one to follow. So in the first one, I multiplied the top equation by negative 3 to get negative 3y and positive 3y, to get those to cancel and solve for x. I got x is 2. I substituted into equation 1, but you could have substituted into equation 2. Either way, you should have gotten negative 6 as your solution for y. And then I'm just representing that as an ordered pair. In number 2, solving this one, I wanted to get the y's to match up, so I multiplied the bottom equation by negative 4 to get 8y and negative 8y. Those lined up, the y's canceled. I substituted negative 7 into the top equation again. Again, you can substitute in either one. You should get the same solution. So that's the idea, is that we can, there's a little bit of wiggle room in choosing how to solve these, but the method is still the same. So I'm going to show you another example of elimination where we've got to multiply both equations by a different numbers. So we're not multiplying just one of the equations by something. So what I would do for this one is I would either get the y's to match up or the x's to match up. It does not matter. But the concept you need to understand is a least common multiple, kind of like finding a common denominator in a fraction. So I'm just going to think to get the y's to match up. So I'm going to think of the least common multiple of 4 and 3 is 12. So that means to get 12, I'm going to multiply the top equation by 3 and the bottom equation by 4 to get the y's to both have coefficients of 12. So the top equation becomes 9x minus 12y equals, and I'm going to do negative 37 times 3 in my calculator to make sure, negative 111. So the bottom equation, multiply everything by 4, negative 20x plus 12y equals, just want to double check, 56. So that's to get the y's to match up. So those cancel. This becomes negative 11x equals negative 111 plus 56 is negative 55. Divide both sides by negative 11. X is 5. Okay? And then I'm just going to take that 5 and substitute it into one of my original equations. I usually just substitute it into the top one. So this becomes 3 times 5 minus 4y equals negative 37. Or 15 minus 4y equals negative 37. And then negative 4y equals negative 52. Y is positive 13. So I get the point positive 5, positive 13 as my solution to that system. Okay? So I want you guys to work on eliminating these, maybe pause me, and then pick it up when I start going through these. So for these, to get the variables to match up, there's going to be something interesting that happens to both of these equations or both of these systems. So to get either x or y to match up, I'm just going to get x's to match up here in the first one. I'm going to multiply the top by -2. So the top becomes -2x plus 6y equals -14. And then the bottom becomes 2x minus 6y equals 12. It stays the same. So the interesting thing I think that happens here is -2x plus 2x is 0. 6y plus -6y is also 0. So this entire side of the equation is 0. And the other side becomes -2, which this is not a true equation, meaning this system has no solutions. And if you graph this in Desmos, you'd see you have two parallel lines, two lines that would never cross. So that's why these have no solutions. So if the result is an untrue equation, that system has no solutions. Okay, moving ahead to the next equation. However you want to get them to match up is up to you. I've got to find a least common multiple. I think I'd rather deal with the smaller numbers, so I'd use 2 and 5. Least common multiple of 2 and 5 is 10, so I'd multiply the top by 5. I'd multiply the bottom by 2. And I don't have to switch signs because they're already opposite signs. And I'll show why those would cancel. So this becomes 10x minus 30y equals 60. And then negative 10x plus 30y equals negative 60. So you're going to notice something that happens here also. 10x minus 10x is 0. Negative 30y plus 30y is 0. That whole side is 0. 60 plus negative 60 is also 0. So this results in a true equation, meaning this has infinite solutions. And again, if you graph this on Desmos to check, you would notice these two lines coincide. They overlap each other. They're the same line. They share all their solutions. So that's why they have infinite solutions. So at the end here, I'd like you guys to work through this guided practice. Pause the video, check in with me. I think hopefully this is making some sense, but elimination is the method I use 90% of the time. Again, substitution is fine. It's a good method, but elimination, it's usually set up in a way that elimination is a little bit easier to follow. So try these, check your answers with me, and ask questions if you've got any issues. Okay, so to finish out these notes, first, number 3, I multiplied the top by -2 to get, or by -4 to get the y's to match up. Incidentally, the x's also matched up, so I got a false equation of 0 equals -11, meaning that system has no solutions. All right, and then in 4, if you get an equation where it's y equals or x equals, that means you got to keep going. That means there's a single solution. So I canceled out the x's, figuring out that the least common multiple of 2 and 5 is 10. So I multiply the top by 5, the bottom by -2 to get the signs to be opposite signs. The x's subtracted to be 0. 15y minus 14y is 1y. That equaled 5. So I substituted 5 into the top equation. I got x is -4. And you can always test those solutions to see if you're solving it correctly. But the main thing is if you're stuck, especially on the practice, use Desmos to graph it and check your solution, or check your answer key, or ask me for help. All of those things are available to you to keep you on pace and keep you going, because your practice right here, where you're trying stuff on your own, is the most important thing to build confidence and to feel like you're actually understanding it. Because if all you're doing is listening to me, I know this stuff. I should know this stuff. The idea is to build your confidence in knowing this stuff and make you guys better problem solvers so you can move on to the next step of the lesson. And again, check in with me if you need any help.